Alright, so here we are with Chapter 3, and this is going to be our Day 2 notes. The Day 2 is going to cover this part here, whereas Day 3 is going to be over here, so we'll just kind of keep that. Alright, like that. So, either way, right now we're going to talk about a function, and basically a function is an equation. So when we start out, for instance, we used to have things like y equals 3x or something like that, okay? So the idea now is that instead of a function, instead of an equation, so this is an equation, we're now going to have a function. So basically instead of a y, we're going to have an f for function, and then from that idea, we're going to end up with a variable. So the idea is that f of x is actually going to equal your 3x. So again, this is read f of x. Alright, and so the idea is that when you use this special notation, when you change y into f, you're actually saying that there's a special type of relationship here, where each domain value or x value has exactly one range value. So we'll kind of talk about that a little bit later in our Day 3 notes. But the idea here is that there is a special relation between these inputs, or whatever you might put in for x, and then what you might get out for y. So, special relation between inputs and outputs. But for the idea of today, basically we're just getting that idea of function, the idea that we're going to kind of pass now on this y as what equals an equation, and we get to move on to this f for function, okay? And that there happens to be a special relation that we'll go over in the next day. So in order to move on from this, we are going to then graph some of these functions, okay? And so down here, notice that we have our new notation here. Instead of a y, we have an f of x, okay? But you can, of course, imagine that any of these y values are the f of x values, and vice versa. So, what we're going to do here is we are going to graph an equation. Now, we did just practice graphing and plotting points. So what we're going to do is fill in this table here with all of the points that we would then plot in order to find our image, okay? So the entire assignment after our one example here is that you're going to fill in a table of values, and then you're going to graph each of those values in order to show that there's a function. So, first thing that we're going to do is pick our first x. Okay, so here we are with -3. So showing your work means that you're going to say that x is -3. And now if I rewrite the equation, which is f of x equals 2x plus 1, notice that I just said that x is actually -3. So that means that any time that I see an x, I'm going to put -3. So in this next step here that's written down, I have that -3 would be inserted in there. Then we would go ahead and simplify, and so now we're going to end up with the simplification of 2 times -3, which is -6, but still a plus 1. And so we finally determine that f of -3, so instead of x, it's now a -3 was plugged in. We're going to get -6 plus 1, which is going to be -5. That means that the coordinate is -3, -5. So, for lack of better words, we're just going to plug in each of these x values in order to see what our y value is so that we can plot it. So the first one there is -5. So if we go ahead and graph that, we've got a -3, -5, and that is going to be our first dot. Alright, so notice here it also says more work. Well, that's because we're going to now plug in -2. So if we plug in a -2, instead of f of x, we're going to have a -2. So f of -2 is what we're looking for, which means that our equation, instead of being 2 times x, is going to be 2 times -2. And plus a 1. If we simplify as we did up above, 2 times negative 2 is going to become negative 4, and we'll still have negative 4 plus 1, and so we'll end up with negative 3. So our next coordinate is negative 2, negative 3. Alright, then we're going to move on and do the next one. So now we're doing f of negative 1. So that means that we're going to have 2 times negative 1 plus 1, which of course is going to simplify from this multiplication to be negative 2 plus 1, or negative 1. Then we go ahead and plug in a negative 2. A 0 is the next number, which means we'll be doing 2 times 0 instead of negative 1 or negative 2. Add a 1 to that, and we get our result of 2 times 0, which is 0, and 0 plus 1, which leaves us with a 1. So again, we're just plugging in for every x, whatever this x in the column is. So the next one is going to be f of 1. And so f of 1 leaves us with 2 times 1 plus 1, but of course 2 times 1 is 2, and so we have 2 plus 1, and that equals 3. So we're just making a list of points. Next one, we're going to plug in a 2. And so we have 2 times 2 plus 1, or 2 times 2, which is 4, plus 1, which is going to equal 5. And then the last one, and maybe you've found a pattern, the fact that it's going up by 2 each time. So I'm going to guess it's 7, but we may as well do the work to show what's happening. So we have f of 3. The fact that that's then going to be 2 times 3 plus 1, or 6 plus 1, which is going to equal 7. So going back up to our graph, if we plot each of these points, we've already done negative 3, negative 5, but negative 2, negative 3 is also one of the points. Then negative 1, negative 1, 0, 1, 1, 3, so over 1 up 3, over 2 up 5, and then the last point of 3, 7 is over 3 up 7. So this is the equation, and the interesting part is that many of you will realize that this is not necessarily just these exact points, right? I could have plugged in 0.5, okay? And so because I could plug in 0.5 or 0.1 or 10, this pattern is going to continue on. And it's also going to include all of the dots between it, okay? So the problem is that some of you will see this as like an endpoint, and you will only graph between the 2 points. But I'm just going to let you know that anytime that you graph this, you always want to have these arrows on the end, okay? Because that is going to indicate that it's going on forever, and that you want to kind of extend the graph past the dots, following that same pattern, okay? So, as we set up above, this domain and range idea is actually going to be in day 3, so we're not doing that right now. And so the rest of what you're going to do is plug in each of these x values into whatever equation is given to find your y values. So again, this is graphing by hand. If you do not have a piece of graph paper, you can always make one. I did post a little video of how to do that, but really you just need a straight edge or a ruler so that you can make some lines here, because I do want this to be slightly accurate. You will only really need a 10 by 10 grid, so it does not need to be that bad. The only other thing that's going to come up in your assignment, so a little bit of a review, is, let's see, an absolute value. Okay, and so we did talk about them a little bit in our previous chapter, in chapter 1, but just to remember that anytime that you take the absolute value of a number, that absolute value idea is actually going to change that into the positive of that number. Okay, so it is always going to be the positive value of that number no matter what you plug in. So again, you could put in a negative number, and even if you put it inside of those absolute values, it's still going to come up with a positive. So basically, taking a look at what we had in the previous one, if I do the absolute value, for instance, of negative 3, the result is going to be 3. If I do the absolute value of 3, the result is going to be 3. Again, these are not opposites of whatever's put in. It's always a positive result. Alright, so hopefully that is going to get you through graphing the next few pieces on your assignment.